Assalamualaikum warahmatullahi wabarakatuh, and hello to my lecturers, Dr. Saada, and my fellow friends. So today, my presentation title is Binocular Balancing, comparison of sphere power between Snellen and Duochrome. So the presenter is Khaila Ahmad, and my partner Nicolau. Introduction. This final step in the subjective refraction is called binocular balancing, a process which is known as sometimes equalizing the accommodation effect. This allows both eyes have retinal image simultaneously in focus. An imbalanced correction often leads to astigmatism because of unstable accommodation. Binocular balancing thus is not to balance the VA but to balance the state of accommodation of the eyes. The objective: first, used for checking estimated compound. Second, matching the accommodative stimulus for the two eyes. Third, relaxes the accommodation as a result of both eyes being open. Enables the matching of the visual acuity between two eyes, particularly in younger patients who can easily accommodate. Lastly, it required because there is a risk of over-minusation during subjective refraction when using Fourier and Snellen charts. Procedure. So as binocular balancing, as we compare the Snellen chart and Duochrome, so we have two procedures here. For using Snellen chart, first, using final description of process method, both eye is fought with positive lens 0.5 ds. Next, ask the patient to look 6-9 line with both eye opens. Occlude right eye subject first, then occlude the left eye. Ask patient which eye is more clearer. For more clearer eye with positive sphere. Repeat procedure 3 and 4 until both eye is not clear. Lastly, stop occlude the eye and reduce the fog lenses by binocular at 0.25 ds. Each time reduce until you get the best binocular view. Okay, using Duochrome, the procedure is as same as Snellen chart for the first, second, and third method, which use final description from Poisson method. Both eye is fought with positive lens 0.5 ds. Ask the subject to look at 6-9 line with both eye opens. Occlude right eye first, then occlude the left eye. Ask subject which eye is more clearer. If one eye see word in red color more brighter, red equal to reduce positive sphere. If one eye see word in green color more brighter, green give positive sphere. With optimal spherical correction, the letters on the red and green half of the chart appear equally clear. And lastly, binocular balancing for Duochrome is done.
Good day, Dr. Saada. So my name is Nicolau, and today my partner and I will be presenting about binocular balancing, comparison of sphere power between Snellen chart method and also Duochrome testing. So previously, Khalila has talked about the introduction, the objectives, and also the procedure of our test. So right now, I'd like to move on to the hypothesis, the results, discussion, and also the conclusion. So the hypothesis is there is no significant difference in the right eye sphere power between using Snellen chart and Duochrome testing between second-year optometry students when performing binocular balancing. To analyze our data, we had used SPSS version 21, and types of statistics we've used is Wilcoxon sign rank test and also descriptive statistics. These are the results obtained. Firstly, we have did the normality testing to test if the data is normal. We have found out that the data is not normal, therefore we have used the Wilcoxon sign rank test to obtain our data. So based on the descriptive statistic, Our number of subjects here are 24 students, and the mean for Snellen chart is a negative 2.47, and the mean for Duochrome is negative 2.80. Okay, moving on to our test statistic. As you can see here, the p-value is 0.002. Okay, moving on to our discussion. Firstly, Snellen chart and Duochrome is two ways to carry out binocular balancing. So binocular balancing is to balance the accommodation of the two eyes. Wilcoxon sign rank test was conducted to compare the sphere power obtained between Snellen chart method and Duochrome test among second year optometry students. Based on the results we obtained, there is a significant difference of the sphere power between using Snellen chart and Duochrome testing when performing binocular balancing. This is obtained based on our results. The p-value previously I've stated is 0.02, and because p-value is less than 0.05, the test has a significant difference. Therefore, the null hypothesis is rejected. Okay. The results of our test could actually be inaccurate due to the small sample size. We have only 24 students in the class, and therefore the sample size is quite small. And also because Duochrome test is quite biased, some patients have selective preferences for a certain color. For example, my hyperopic patient prefer to look at the green color, therefore green color appears slightly clearer than the red color. And also because Snellen chart is actually more effective compared to Duochrome, because Snellen chart is much easier for the patients to differentiate. Therefore, moving on to our conclusion, there is a significant difference in the right eye sphere power between using Snellen chart and Duochrome testing between second year optometry student when performing binocular balancing. That is all for our presentation today. Thank you.